Greetings to you, my global audience. I'm thrilled to have you here as we step into another live stream of the digital revolution, where intelligent technologies, where Industry 4.0, and where human ingenuity intersect and reshape how the world works in the AI industrial age. On this live stream, we're talking about the industrial Internet of Things, a space where physical assets become intelligent collaborators. Data becomes a strategic resource, and entire operations evolve from reactive to predictive. Whether you're joining us from the manufacturing, from energy, infrastructure, or the broader global industrial ecosystem, this conversation is built for you. This isn't just about sensors or dashboards, it's about unlocking a new value, rethinking workflows, and preparing our businesses and our people for a connected future that's already unfolding around us. So settle into this broadcast, get engaged, and let's explore how the industrial Internet of Things is transforming industries, empowering decision makers, and driving the next wave of innovation. The revolution isn't coming, it's here, and you're part of it. Let's talk about why the industrial Internet of Things matters now in the era of digital transformation. The industrial Internet of Things has moved from an emerging concept to a strategic necessity because the industrial world is under unprecedented pressure to operate smarter, operate faster, and operate more sustainably. Businesses are no longer competing on products alone. They're competing on data, responsiveness, and the ability to anticipate problems before they occur. Industrial Internet of Things provides the connective tissues that make this possible by linking the sensors, the equipment, the software, and the analytics into a unified ecosystem. Companies gain real-time visibility into operations that were once opaque. This shift from reactive to predictive decision making is transforming everything from maintenance strategies to energy consumption, supply chain reliability, and workforce safety. Now, at the same time, digital transformation has raised expectations across every sector. Stakeholders want transparency, regulators demand traceability, and customers expect reliability. Industrial Internet of Things delivers the data foundation required to meet these expectations while enabling continuous improvement at scale. It empowers businesses to modernize legacy assets without replacing them, bridge the gap between information technology and operational technology, and to unlock new business models built on insights rather than assumptions. In a world where industrial downtime, inefficiency, and waste carry enormous financial and also environmental cost, the industrial Internet of Things isn't just a technology upgrade. It's a competitive advantage, a catalyst for long-term resilience. Now, the big picture, industrial Internet of Things in Industry 4.0 and the digital revolution. So the industrial Internet of Things is just one of the center pillars of Industry 4.0, the fourth industrial revolution that fuses the physical production with digital intelligence. We're early in the revolution, things were driven by mechanization, electrification, and automation. Industry 4.0 is defined by the connectivity and data. Industrial Internet of Things provides an infrastructure that allows machines, sensors, and systems to communicate seamlessly, creating a cyber-physical environment where every asset is both a producer and a consumer of information. Now, this interconnectedness enables factories, pipelines, and energy grids to operate as a dynamic ecosystem rather than isolated units. By unlocking efficiencies and insights that were previously impossible. And in the broader digital revolution, industrial Internet of Things represents the industrial counterpart to the consumer, which is the Internet of Things world. Just as smart homes and wearable devices have transformed our personal lives, the industrial Internet of Things is reshaping how industries function at scale. It bridges the operational technology with the informational technology And this allows businesses to harness advanced analytics, artificial intelligence, and cloud computing to drive predictive maintenance, optimize supply chains, and reduce environmental impact. By embedding intelligence into the very fabric of industrial infrastructure, the industrial Internet of Things ensures that digital transformation is not just confined to the offices or to consumer markets, it permeates the backbone of global economies. In this way, industrial Internet of Things is not just a technological upgrade, it's the connective forces that make Industry 4.0 real, scalable, and transformative. So let me ask you this. What what's the most valuable data your operation isn't capturing yet? Industrial Internet of Things fundamentals, what it is really. So, to understand the differences, Internet of Things, the IoT, most people are familiar with with this, and it lives in the consumer world. You have smart thermostats, fitness trackers, home assistants, connected appliances, and wearables. And these devices are designed for convenience, personalization, and lifestyle enhancement. Where typically, and this operates in standard Wi-Fi or on Bluetooth networks, and they handle relatively small amounts of data. It can tolerate occasional downtime or connectivity issues. If your smart speaker glitches or your fitness tracker needs a reboot, it's inconvenient, but it's not catastrophic. Now, consumer Internet of Things is built around accessibility, ease of use, and rapid adoption, with security and reliability important, but not mission critical. When it comes to the industrial Internet of Things, by contrast, this operates in environments where failure is not an option. Industrial Internet of Things connects heavy equipment, pipelines, manufacturing lines, power grids, transportation systems, and other mission critical assets. And these systems must withstand harsh conditions, deliver real time data with near zero latency, and integrate with complex operational technology that may be decades old. So, reliability, safety, and cybersecurity are paramount because a single failure can halt production, damage infrastructure, or put workers' lives at risk. Industrial Internet of Things networks often use specialized industrial protocols, edge computing, and redundant architectures to ensure continuous operation. In short, Internet of Things enhances everyday life, while industrial Internet of Things transforms industrial performance. One is built for convenience, while the other is engineered for resilience, precision, and operational excellence. This distinction is essential for understanding why industrial Internet of Things requires different strategies, different technologies, and importantly, governance, and why it plays such a pivotal role in the broader digital transformation of global industries. So, the core components of industrial Internet of Things, we're going to talk about sensors, connectivity, edge devices, the cloud, and analytics. At the foundation of every industrial Internet of Things ecosystems are sensors. And these are the frontline instruments that capture real world data from industrial assets. These sensors measure everything from temperature, vibration, pressure, flow rates, even corrosion potential, and equipment health indicators. In traditional operations, this information was often collected manually or intermittently. Industrial Internet of Things transforms that model by enabling continuous high resolution data capture. And the quality, frequency, and accuracy of sensor data directly influence the value of the entire industrial Internet of Things stack, making sensors the essential eyes and ears of connected industrial environment. Once data is captured, connectivity becomes the lifeline that moves information across the system. Industrial environments rely on a mix of wired and wireless technologies. It could be Ethernet, cellular, long range, wide area networks, which are based on radio connectivity, Wi Fi, and specialized industrial protocols to ensure reliable, low latency communication. Unlike consumer Internet of Things, industrial connectivity must withstand harsh conditions, electromagnetic interference, and long distances while maintaining security and uptime. This is where edge devices play a crucial role. Positioned close to the equipment, edge devices pre process data, They filter noise and they run local analytics so that only meaningful information travels upstream. This reduces bandwidth demands, it improves response times, and it allows critical decisions to be made even if the cloud connectivity is disrupted. At the top of the architecture sits the cloud, where large scale storage, advanced analytics, and machine learning models operate. The cloud enables businesses to aggregate data from multiple sites, compare performance across assets, and run complex simulations or digital twins. It's a strategic layer where long term insights, predictive maintenance models, and enterprise wide dashboards come to life. Finally, analytics, the intelligence engine of industrial Internet of Things. This turns raw data into actionable outcomes. Whether performed at the edge or on the cloud, analytics reveal patterns. They predict failures, they optimize energy use, and they support data driven decision making. Together, these components form a cohesive ecosystem that transforms industrial operations from reactive to predictive, and from siloed to connected, and from manual to intelligence. Let's talk about the role of cyber physical systems in industrial Internet of Things. Cyber physical systems, which I will refer to as CPS moving forward, they're the backbone of modern industrial transformation because they merge the physical world of machines, equipment, and infrastructure with the digital intelligence of software, data, and automation. In a CPS environment, sensors are connected devices that continuously monitor physical processes, while digital systems analyze that data and respond in real time. This creates a closed feedback loop where physical actions generate data, digital intelligence interprets it, and automated or human guided decisions that adjust the operations instantaneously. The result is a smarter, more adaptive industrial ecosystem where equipment doesn't just operate, it actually collaborates, it learns, and it optimizes itself. Within the industrial Internet of Things landscape, CPS it elevates industrial operations from static to reactive to dynamic and predictive. They enable capabilities like digital twins, autonomous processes controls, and real time optimization across entire facilities or distributed assets. For example, a cyber physical system in a pipeline network can detect pressure issues, analyze them at the edge, and trigger automated responses long before a human operator can intervene. In manufacturing, CPS synchronizes robotics, quality control systems, and production planning to reduce waste and increase throughput. By tightly integrating computational with physical processes, CPS makes Industry 4.0 possible, turning data into action, action into insight, and insight into continuous improvement. Now, for the shift from reactive to predictive operations, for decades, industrial operations relied on a reactive model, and this is waiting for equipment to fail, processes to drift out of spec, or systems to show visible signs of trouble before taking action. And this approach was costly, it's inefficient, and it's often risky. Downtime could hold production, it could disrupt supply chains, or it could compromise safety. Maintenance teams were forced into a cycle of firefighting rather than strategic planning. And in today's fast moving industrial landscape, that model simply can't keep up with the demands for higher uptime, tighter margins, and greater operational transparency. Predictive operations powered by the industrial Internet of Things, this flips the paradigm completely. Instead of reacting to failures, businesses use real time sensor data, edge intelligence, and advanced analytics to anticipate issues before they occur. Equipment health indicators, vibration patterns, temperature shifts, pressure issues, corrosion rates, they're continuously monitored and analyzed to detect early warning signs. And this enables maintenance to be scheduled proactively, resources to be allocated more efficiently, and operations to run far greater stability. Predictive operations don't just prevent failures, they optimize performance, extends asset life, and it creates a culture where decisions are driven by insight rather than urgency. And in a world where every minute of uptime matters, this shift is one of the most transformative outcomes of industrial Internet of Things adoption. The industrial value chain, where industrial Internet of Things delivers impact. The industrial Internet of Things is reshaping asset monitoring by turning one silent equipment into continuously communication systems. Sensors embedded in pumps, valves, compressors, on pipelines, and rotating machinery, they stream constant real-time data on performance, environmental conditions, and structural health. This constant visibility eliminates blind spots that were previously led to unexpected failures or inefficient manual inspections. Operators can now see exactly how assets are behaving under load, how conditions change over time, and whether early warning signs are emerging. This level of transparency not only improves reliability, but it also empowers teams to make faster, more informed decisions and also better budget planning. Predictive maintenance is one of the most transformative outcomes of industrial Internet of Things adoption. Instead of relying on fixed schedules or reacting to breakdowns, businesses use data analytics and machine learning to anticipate failures before they occur. Vibration issues, temperature spikes, pressure deviations, and corrosion indicators can be detected long before they escalate into a costly downtime. And this shift reduces maintenance costs. It extends asset life cycles and dramatically increases uptime. It also frees up maintenance teams from constantly firefighting and allows them to focus on strategic improvements rather than emergency repairs. For process optimization and automation, they also benefit equally from the industrial Internet of Things intelligence layer. With real-time data flowing across production lines or distributed infrastructure, systems can automatically adjust parameters to maintain efficiency, quality, and throughput. Industrial Internet of Things enabled automation ensures that processes remain stable even under variable conditions, reducing waste and improving consistency. And in many industries, this means tighter control over energy use, raw materials, and operational performance. And key drivers are both profitability and sustainability. Worker safety and remote operations are also elevated by industrial Internet of Things technologies. Connected sensors can detect hazardous conditions, it can monitor worker locations and trigger alerts when thresholds are exceeded. Wearables and smart PPE add another layer of protection by providing real-time health and environmental data. Meanwhile, remote operations that are powered by edge computing, secure connectivity, and digital twins, this allows teams to monitor and control assets from anywhere. This reduces the need for personnel to enter dangerous environments, and it enables expert oversight across multiple sites without physical travel. And in a world where safety, efficiency, and resilience are non-negotiable, the industrial Internet of Things delivers capabilities that fundamentally change how industrial business operates. Let's talk about cybersecurity and industrial Internet of Things, the non-negotiable layer. As industrial operations become more connected, cybersecurity shifts from an IT concern to a mission-critical operational requirement. Industrial Internet of Things environments blend sensors, controllers, cloud platforms, and legacy equipment into a single digital ecosystem, while creating an expanded attack surface that adversaries are eager to exploit. Cybersecurity in industrial Internet of Things isn't just about protecting data, it's about safeguarding physical processors, worker safety, and the continuity of essential services. A breach in an industrial system can shut down production lines. It can disrupt energy distribution or compromise critical infrastructure. That's why cybersecurity must be embedded into every layer of industrial Internet of Things architecture, from device authentication to encrypted communication to network segmentation and continuous monitoring. Industrial systems are high-value targets because they control assets that keep economies running. Pipelines, power grids, water treatment facilities, and manufacturing plants are attractive to attackers seeking financial gain, geopolitical leverage, or operational disruption. And many of these environments were never designed with connectivity in mind, making them very susceptible once they're brought online. Legacy equipment often lacks built in security features and it relies on the perfect storm, the, the highly valuable systems with limited inherent protection, now exposed to modern cyber threats. Governance, compliance, and risk frameworks provide the structure that business needs to manage these challenges. Standards help define best practices for screening industrial control systems and industrial Internet of Things deployments. These frameworks guide everything from asset inventory to vulnerability assessments to incident response and continuous improvement. Strong governance ensures that cybersecurity isn't treated as a one time project, but an ongoing discipline woven into operational culture. By aligning technologies, processes, and people under a unified risk strategy, businesses can confidently adopt the industrial Internet of Things while maintaining the resilience and reliability that industrial environments demand. So let's talk about some real world cases. In pipeline integrity monitoring, industrial Internet of Things is becoming a game changer, and this enables continuous data-driven oversight of assets that once relied heavily on periodic manual inspection. Now, operators can now deploy distributed sensors that track pressure, the flow, the vibration, the temperature, and also acoustical signatures along a vast pipeline that's buried. These sensors feed real-time data into edge devices and cloud platforms, and this allows uncharacteristic events such as leaks, pressure drops, or unusual vibration patterns to be detected instantly. One major operator, for example, based on my research, they actually had integrated some industrial Internet of Things sensors, and with a machine learned model, AI model, they were able to identify micro cracks and micro leaks that were happening long before they became catastrophic. And this would have been very difficult to capture through traditional methods. Now, this shift not only reduces environmental risk, but it can save millions in potential downtime and also repair costs and also avoid catastrophic events. Industrial Internet of Things has effectively turned pipelines into self-reporting systems that enhance safety, reliability, and also regulatory compliance. Now, corrosion and coatings lifecycle analytics have also been transformed by Industrial Internet of Things. Historically, corrosion monitoring depended on manual processes, visual inspections, and scheduled maintenance cycles. Today, smart corrosion probes, humidity sensors, and coating health monitors that can provide continuous insight over environmental conditions and the material condition. In one case, a global energy company deployed an industrial Internet of Things enabled corrosion sensor across some offshore assets. And this allowed engineers to track corrosion rates in real time and adjust maintenance schedules based on the actual conditions rather than just assumptions. And this data-driven approach extended the coating life, it reduced unnecessary recoating, and also improved asset longevity. The industrial Internet of Things has shifted corrosion management from reactive to predictive, and this gives operators the ability to intervene before damage even escalates. When it comes to energy infrastructure, from substations to renewable installations, the benefits from industrial Internet of Things through enhanced visibility and automated control. Utilities use industrial Internet of Things sensors to monitor transformer health, grid load, temperature fluctuations, and equipment vibration. In one deployment, a utility integrated industrial Internet of Things sensors with digital twins to simulate round behavior under stress. This enabled proactive load balancing and preventing outage during peak demands. And renewable energy sites such as wind farms and solar arrays can use the industrial Internet of Things to optimize performance by tracking blade vibration, inverter efficiency, and environmental conditions. And these insights really help operators maximize output while reducing maintenance costs and unplanned downtime. Remote asset management in hazardous environments and other areas where industrial Internet of Things delivers enormous value. Facilities such as chemical plants, offshore platforms, and mining operations often require personnel to enter into dangerous zones for inspections or manual readings. The industrial Internet of Things eliminates such that risk by enabling remote monitoring and control. To give you an example, an offshore operator deployed industrial Internet of Things sensors combined with edge analytics to monitor equipment in high risk zones. And this allowed engineers offshore or onshore, to assess conditions and make decisions without even seeing or sending workers to those hazardous areas. This not only this improvement of safety, but it also accelerated response time, reduced operational costs. So industrial Internet of Things empowers businesses to protect their workforce while maintaining high levels of operational performance, even in the most challenging environments. Now, for the human element, we're going to talk about workforce plus company culture. Even with all the technology driving the industrial Internet of Things, the real transformation happens through people. A connected industrial ecosystem only succeeds when the workforce is equipped, empowered, and confident in using new tools and data. Industrial Internet of Things changes how decisions are made, how teams collaborate, and how work gets done. That shift requires more than technical training. It demands a cultural evolution. Workers must move from relying on intuition and experience alone to embracing data-driven insights. When businesses invest in upscaling, cross-training, and digital literacy, they create a workforce that can interpret sensor data, understand predictive analytics, and collaborate effectively with automated systems. This blend of human judgment and digital intelligence becomes a powerful competitive advantage. And culture is equally critical. Industrial Internet of Things adoption often challenges longstanding habits, workflows, and comfort zones. Successful businesses cultivate a culture of curiosity, transparency, and continuous improvement. They encourage teams to experiment, learn from data, and share insights across departments. And this is especially important as information technology and operational technology convergence, two worlds that historically operate in silos. When leaders model openness, celebrate small wins, and communicate the why behind digital transformation, they reduce the resistance and they build trust. Ultimately, the industrial Internet of Things is not just a technological upgrade, it's also a cultural shift towards smarter, safer, and more collaborative operations. The businesses that thrive are the ones that recognize that people, not sensors or algorithms, are at the heart of the digital revolution. So let me just say that the core message of this live stream is that the industrial Internet of Things is no longer a future concept. It's present here today. It does give a competitive advantages, and businesses that embrace connected assets, real-time data, and predictive intelligence are already seeing gains in uptime, safety, efficiency, and sustainability. Industrial Internet of Things transform operations from reactive to proactive, and this breaks down silos between the information technology side and the operational technology side. And it also empowers teams with insights that were impossible just a few years ago. So whether it's in pipeline integrity, corrosion lifecycle analytics, energy infrastructure, or remote operations, the value is clear. Smarter systems lead to stronger performance. And the digital revolution isn't about replacing people, it's the equipping them with better tools, better data, and better decision-making power. So the call to action is simple. Start where you are, but start now. You don't need a massive overhaul to begin your industrial Internet of Things journey. Modular adoption, pilot projects, and targeted use cases can deliver fast return on investment models and build internal momentum. Invest in your workforce, strengthen your cybersecurity posture, and choose partners who understand both the technology and the realities of industrial operations. And most importantly, cultivate a culture that embraces data, curiosity, and continuous improvement. The businesses that take action today will be the ones that are leading their industrial tomorrow. and the digital revolution is underway. And the industrial Internet of Things is your pathway to resilience, innovation, and long term success. So, with that, I'd like to say thank you for joining me in this live stream. I want to wish you a very good evening, night, or day, no matter where in the world you're watching this broadcast. Thank you.